All right, today we're diving into a paper called MCP0, and it poses a really fascinating question. What if we stopped force-feeding AI all the tools we think it might need, and instead we just taught it how to ask for help? It's a simple idea on the surface, but it could completely rewire how we build AI agents. This quote from John Dewey, which the paper opens with, is the perfect way to frame this. It really gets to the heart of the difference between an AI that just passively picks from a menu and one that actually confronts a problem and has to figure out what it needs to solve it. So, what's the big issue that MCP0 is trying to fix? Well, to put it simply, we're taking these incredibly powerful AI models and we're turning them into overwhelmed, inefficient assistants. The way we give them tools right now is just clunky. Right now, there are basically two main ways we do this. And honestly, they're both pretty flawed. The first method is what we can call the giant backpack. You basically stuff every possible tool into the system prompt. The other method is the one guess, which uses retrieval to try and guess the right tool beforehand. One is just totally overwhelming, and the other is basically a shot in the dark that fails the moment a task takes an unexpected turn. And when we say giant backpack, we are not kidding. To load a big tool ecosystem like the one they test, the Model Context Protocol, you're looking at nearly 250,000 tokens. That is an absolutely massive amount of information for the AI to have to sift through for every single thing it does. And here's the real kicker. These methods don't empower the AI, they just bog it down. Instead of getting a smart, autonomous agent that can reason, you get something that acts more like an overwhelmed database, just struggling to find the right file in a giant, messy cabinet. Okay, so if that's the problem, what's the solution? MCP0 proposes a pretty fundamental shift in thinking. What if, instead of shoving tools at the AI, we just taught it how to ask for exactly what it needs, right when it needs it? The core idea is called active tool discovery. The AI stops being just a passive selector. Instead, it actively diagnoses its own capability gaps. It figures out what it can't do on its own, and then it specifically asks for the tool that will fill that gap. I mean, just think about what a huge change this is. The agent goes from being a passive tool user to an active tool requester. We're basically restoring its ability to actually think about the problem in front of it instead of just managing a clunky inventory. So how does this actually work under the hood? Well, MCP0 is built on 3 core mechanisms that work together in a really slick, elegant way. It all happens in 3 stages. First, the active tool request, where the AI generates a really specific structured request for what it needs. Then hierarchical semantic routing kicks in. Think of it like a super smart librarian who first finds the right aisle and then the exact book on the shelf. And finally, iterative capability extension. This is the magic part. The AI can keep asking for new tools as the problem unfolds, building out its abilities on the fly. Okay, theory is great, but let's make this real. Imagine you give the AI a pretty common task. Hey, can you debug my code in this file, train.py? The AI's first thought is simple and completely logical. All right, to debug this code, I first need to actually read the file. It immediately sees its first capability gap. It can't see the code yet, so it makes a super specific request for a tool that lets it read a file. Simple. So once it has the code, its understanding of the problem evolves. It finds the bug, and its next thought is, okay, now I need to fix the code. It realizes the reading tool it just used isn't going to cut it. It needs a new capability, editing, and so it asks for the exact tool to do that job. And here is the final crucial step. After it makes the edit, the AI thinks, right, I need to run this thing and see if my fix actually worked. This requires a totally different kind of tool, something that can execute commands in a terminal. And just like that, it built a complex, multi-step solution on its own, one step at a time. This all sounds brilliant, right? But the real question is, does it actually work in practice? Well, the researchers put MCP0 through some seriously tough tests to find out. Their first big experiment was a classic needle in a haystack test. The question was simple, but brutal. Can the AI find the one correct tool it needs when that tool is hidden away in a massive library of almost 3,000 other tools? And the results, they're pretty remarkable. The standard giant backpack method really starts to choke as the library of tools gets bigger, even for a super capable model like Claude 3.5 Sonnet. But with MCP-0, the accuracy stays incredibly high. It finds that needle in the haystack again and again. But accuracy is only half the story. Now for the number that is just truly jaw-dropping. In tests on a benchmark called API Bank, MCP-0 got a 98% reduction in token consumption. Let's just pause and let that sink in for a moment. This isn't some small optimization. We are talking about a 98% shorter prompt. The AI is doing the same complex job with the same high level of accuracy, but it's using a tiny, tiny fraction of the computational resources. It's not just a little bit better, it's wildly more efficient. And this chart really shows you why that efficiency is such a game changer. With the standard method, the token cost just skyrockets as you add more tools. It's totally unsustainable. Meanwhile, look at MCP-0's cost. It stays flat and incredibly low. This is a system that can actually scale to real-world complexity. So what does this all mean? Why is a more efficient way for an AI to use tools such a big deal? Well, this research isn't just about an incremental improvement. It's really pointing to an entirely new, and frankly better, way of building AI agent systems. So let's just boil it all down. What are the big takeaways here? First, you get massive efficiency, which slashes costs and computation. Second, you get robust scalability. It doesn't break as things get more complex. And third, and this might be the most important one, it restores the AI's autonomy. It lets it become a true problem solver again. This is a fundamentally new and better design pattern for these systems. And that really brings us to the final thought I want to leave you with. The paper even hints at a future where MCP-0 could be combined with systems that can create new tools on the fly. So, if an AI can actively find any tool it needs and potentially create any tool that doesn't exist yet, what kinds of problems we once thought were impossible, are now finally within our reach?